In 1924, a French engineer buried a short length of copper wire in his vegetable garden. No chemicals, no compost, no fertilizer of any kind. Within one growing season, his crop yields had doubled. Within 2 seasons, over 150,000 gardeners across Europe were doing the exact same thing. Then, almost overnight, the method vanished. The wire was pulled from the ground. The research was shelved. The books went out of print. And for the next century, gardeners around the world kept hauling heavy bags of synthetic fertilizer home from the garden center, never knowing that a nearly free alternative had been quietly buried, not in the soil, but in history. This is the story of that forgotten trick. It involves a brilliant inventor who was pushed out of the conversation, a suppressed government report that sat locked in filing cabinets for decades, the shimmering glow of the northern lights, and a combination of 3 simple items sitting in most kitchens right now. More importantly, it is a story that ends in a garden, perhaps yours, where tired, gray soil comes back to life without a single bag of chemicals. And the setup takes less than 5 minutes. 1. The 1920s miracle that quietly disappeared. The 1920s were a strange crossroads for agriculture. On one side stood industrial chemistry, promising to feed a growing world with synthetic nitrogen manufactured in massive factories. On the other stood a quieter movement, a scattered group of farmers, engineers, and scientists who believed the answer was already in the air. Literally in the air. Not as a metaphor, but as a measurable physical force that plants had been feeding on since long before humans ever planted a seed. Among them was Justin Christofleau, a French engineer and agronomist with a claim so bold it sounded almost reckless. He could increase crop yields by as much as 200% using nothing more than copper and zinc antennas planted directly in the soil. No fertilizer, no ongoing cost, no subscription, no annual purchase, just a one-time setup that took a few minutes and a few centimeters of metal wire. Christofleau was not guessing, and he was not working from theory alone. He built what he called a potager électrique, an electric vegetable garden, on his own land and recorded the results with the precision of an engineer. His simple copper and zinc devices, designed to capture what he described as electromagnetic terrestrial energy, produced faster seed germination, visibly accelerated plant growth, and a striking resistance to both drought and disease. Neighbors could see the difference from across the fence. The results were so consistent, so repeatable, that over 150,000 of his devices were sold to farmers and home gardeners before the outbreak of World War II. 150,000. That is not a fringe movement. That is a continent paying attention. So here is the question that deserves an honest answer. If this worked so well, and so many people saw it with their own eyes, where did it go? The timing tells the story. The same decade that Christofleau was selling his copper antennas, the Haber-Bosch process for manufacturing synthetic nitrogen was scaling into a global industry worth billions. Giant agrochemical corporations were building their entire business model around one core assumption: that farmers would buy fertilizer every single season, year after year, generation after generation. A one-time copper wire that pulled free energy from the sky did not fit that model. It did not just fail to fit, it directly threatened the economics of the entire industry. Christofleau himself wrote that he faced relentless opposition from lobbyists connected to the chemical fertilizer sector. Whether that opposition was coordinated or simply the natural pressure of a dominant industry protecting its market is a matter of interpretation. But the outcome is not debatable. His method faded from public knowledge. Meanwhile, across the English Channel, the British government had been running its own investigation. A body called the Electroculture Committee operated quietly from 1918 to 1936, nearly 2 decades of experiments. Their trials showed measurable, reproducible increases in crop yields using electrical methods. But when the committee was dissolved, the findings were filed away and never published for public use. The records exist. The data was real. But it never reached the people who could have used it most. The gardeners and small farmers who were already struggling to afford the chemicals that had just replaced the free alternative. The chemical age rolled forward, and Christofleau's work was forgotten. Not because it failed, not because it was disproven, but because it was overtaken by an industry with deeper pockets and louder voices. That is not conspiracy. That is economics. But here is the part of the story that matters most. Science has a long memory. And what researchers are uncovering today suggests that those early pioneers were onto something far bigger than a gardening trick. They had stumbled onto a fundamental truth about how plants actually grow. 2. The Northern Lights and the discovery of living electricity. Most gardeners understand the basics. Plants need sunlight. They need water. They need nutrients from the soil. But there is a fourth ingredient, one that almost nobody talks about, one that has been documented by scientists since the 18th century, but somehow never made it into a single gardening book on the shelf at the local library. That ingredient is atmospheric electricity. The story begins in 1783, when a French scientist named Abbé Pierre Berthelon noticed something peculiar during his experiments with plants and weather. Plants exposed to atmospheric electrical fields, the kind that build naturally in the air during certain weather patterns, grew noticeably faster and stronger than plants that were shielded from those fields. Berthelon was so convinced of the connection that he designed and built a device he called the electrovegetometer, engineered specifically to channel electricity from the air into crop beds. By modern standards, the device was primitive, but the underlying principle was sound, and, more importantly, it worked. The crops responded. Nearly 60 years later, in 1841, the Scottish inventor Alexander Bain pushed the concept further. Bain created what he called an earth battery, pairs of copper and zinc plates buried in the soil, generating a mild electrical current from the chemical interaction between the metals and the damp earth. Farmers who installed his system noticed something unmistakable. Plants grown between those buried plates grew faster, stood taller, and produced heavier harvests than anything in the surrounding fields. The effect was visible, it was repeatable, and it cost almost nothing after the initial setup. But the most dramatic evidence came from a place no one expected: the frozen edge of the Arctic Circle. In the late 1800s, a Finnish geophysicist named Carl Selim Lemström, a professor at Helsinki University, traveled north to study the aurora borealis. The northern lights were his primary subject. But what he found in the landscape beneath them shifted his entire understanding of plant biology. In these extreme northern environments, places with brutally short growing seasons, weak sunlight, and soil that spent most of the year frozen, the vegetation was not stunted. It was thriving. Trees grew surprisingly tall. Ground cover was deep green and vigorous. Wildflowers bloomed with an intensity that seemed impossible given the conditions. Lemström spent years investigating. His conclusion, published in 1904, was both simple and profound. The highly charged electrical atmosphere generated by the aurora borealis was pouring invisible energy into the plants below. Not through the soil, not through the roots, through the air. The plants were absorbing electrical energy directly from the atmosphere, feeding on it, growing from it, responding to it as actively as they responded to sunlight and water. That discovery changed nothing at the time. It was published, acknowledged by a small circle of academics, and then quietly absorbed into the footnotes of geophysics textbooks. It never crossed over into practical agriculture or home gardening. But it contains the single most important insight behind everything that follows. Plants are electrical organisms. They do not just tolerate electricity. They use it. They need it. And for most of their evolutionary history, they have had access to far more of it than they get in a typical modern garden bed. That raises an obvious question. If the atmosphere is full of this energy, and plants have been feeding on it for millions of years, is there a way to give a backyard garden the same advantage that Arctic wildflowers get from the northern lights? The answer, as it turns out, involves nothing more complicated than a piece of copper wire. 3. The copper spiral, giving the sky a ladder. Here is a fact that changes the way a person looks at an ordinary afternoon in the garden. On any clear, calm day, no storm, no wind, just quiet sunshine, the atmosphere carries a positive electrical charge. There is a natural voltage gradient stretching from the ground to the sky, measuring roughly 100 to 150 volts per meter. To put that in everyday terms, stand in the garden, hold a hand up over your head, and there is more voltage between the ground and that raised hand than a standard AA battery produces in total. The difference is, this atmospheric energy is everywhere, all the time, and it costs nothing. Plants are sitting in this invisible ocean of electrical energy every single day. But most of that energy passes right over them without making meaningful contact. The leaves are not tall enough, not conductive enough to capture it efficiently. The 1920s trick solves that problem in the simplest possible way. It gives the energy a path, a physical ladder to climb down from the atmosphere into the root zone where the plant can actually use it. The setup takes less than 5 minutes, and any gardener can do it without bending, kneeling, or straining. Take a length of bare, uninsulated copper wire. That word bare is critical. Any plastic coating, any enamel finish blocks the electrical connection and defeats the purpose. Bend the wire gently into a spiral or helix, roughly 30 centimeters across. That is about the size of a standard dinner plate. Leave a straight section at the bottom, like a stem, roughly 15 to 20 centimeters long. Push that straight end into the soil beside a plant. The spiral portion stays above ground, extending above the mature height of the plant. That is the entire installation. No tools, no digging, no heavy lifting. If the wire is long enough, the whole thing can be planted while standing upright. What has just been created is a passive antenna. It captures the voltage gradients and ambient radio frequencies drifting through the atmosphere and channels tiny electrical currents, microcurrents measured in millivolts, directly into the soil surrounding the roots. There is no battery, no power source, no moving parts, no maintenance. The copper simply sits there, day and night, season after season, quietly pulling microenergy from the air and feeding it to the root zone. A roll of bare copper wire at the hardware store costs less than a cup of coffee. One roll serves an entire garden. But on its own, the copper is only half the equation. The next step, using 2 items that most people throw in the trash, is what separates a mild effect from a dramatic one. 4. The kitchen secret that supercharges the wire. Here is the detail that separates gardeners who try electroculture and shrug from those who try it and never look back. The copper antenna can pull energy from the sky, but that energy needs a conductive path through the soil to reach the roots. If the surrounding earth is dry, compacted, or stripped of minerals, which describes most garden beds after years of chemical-only treatment, the current has nowhere to go. It stalls at the surface. The antenna becomes decoration. The fix is almost embarrassingly simple, and it comes from 2 things that most households throw away every single week: wood ash from a fireplace, a wood stove, or a backyard fire pit, and used coffee grounds from the morning pot. Think of the soil as a battery. For any battery to function, it needs electrolytes, dissolved minerals that carry an electrical charge through a liquid medium. Wood ash is quietly one of the most mineral-rich substances available to a home gardener. It is loaded with potassium, calcium, and magnesium, all of which dissolve readily in soil moisture and break into charged particles called ions. When a light dusting of wood ash is sprinkled around the base of the copper wire, the surrounding soil becomes dramatically more conductive. The tiny electrical current from the copper now has a clear, easy path directly to the plant roots. In the simplest possible terms, the ash turns dead dirt into a live wire. Now add the second ingredient. Used coffee grounds, mixed into the same area of soil, bring nitrogen and organic matter into the equation, both valuable on their own. But their real advantage in this particular system is physical texture. Coffee grounds are highly porous. They absorb and hold moisture the way a sponge does, keeping the electrical pathway active even during dry spells when the surrounding soil might otherwise lose its conductivity. They hold just enough dampness to keep the current flowing without waterlogging the roots. And here is a side effect that surprises nearly everyone who tries it. The combination of mild electrical current from the copper wire and the rich, earthy scent of decomposing coffee grounds attracts earthworms. Earthworms are remarkably sensitive to electrical fields. It is one of the primary ways they navigate underground. Many gardeners who have installed this system report seeing a noticeable surge in earthworm activity within the first 30 days. More earthworms means more natural aeration, more nutrient-rich castings deposited directly in the root zone, and a self-reinforcing cycle of soil improvement that compounds over time. So the copper pulls energy from the atmosphere. The ash conducts it to the roots. The coffee holds the moisture and recruits the earthworms. 3 free ingredients, working together as a single system that improves with age rather than depleting with use. No bag of synthetic fertilizer on the market does that. But does any of this hold up under the scrutiny of modern laboratory science? That question sat unanswered for decades. Then, a handful of serious researchers decided to test it. And what they found surprised even the skeptics. 5. What cutting-edge science actually found. For most of the 20th century, electroculture was treated by mainstream agriculture the way folk remedies are treated by modern medicine. Interesting as history, not credible as science. The chemical fertilizer industry dominated every conversation about crop yields, and the idea that a copper wire could replace a bag of ammonium nitrate sounded, frankly, absurd to the academic establishment. Nobody with a serious research career wanted to stake their reputation on testing a method that had been forgotten for half a century. That changed in 2006, when Dr. Andrew Goldsworthy, a plant biotechnologist at Imperial College London, published a study that reframed the entire conversation. What Goldsworthy discovered was not just that plants respond to electrical fields. Scientists had known that for centuries. What he uncovered was why they respond, and the answer was elegant, intuitive, and immediately convincing. Plants respond to mild electrical fields because those fields perfectly mimic the electrical signature of an approaching thunderstorm. Consider what happens in nature when a storm builds on the horizon. Long before the first raindrop falls, the atmosphere fills with electrical charge. The air crackles with it. Over hundreds of millions of years of evolution, plants develop the ability to detect that charge. When they sense it, they shift into emergency growth mode, rapidly activating genes, accelerating their metabolism, and pulling in as much water and nutrients from the soil as physically possible before the coming downpour washes those nutrients away. It is a survival mechanism, refined over millennia, hardwired deep into plant biology. A copper spiral sitting in a garden bed triggers that exact same response. The plant has no way to distinguish between a real approaching storm and a gentle, constant stream of microcurrent from a length of copper wire. It simply senses the electrical field and does what millions of years of evolution have taught it to do: grow faster, root deeper, absorb everything available, prepare for rain that, in this case, never needs to come. More recent research pushed the evidence further. In 2023, a study published in the journal Bioelectromagnetics by researchers Mohammed Abhari and Abdullah Akka tested a modern variation of the concept called magnetopriming. They exposed tomato seeds to a carefully measured magnetic field using small neodymium magnets, essentially a controlled modern version of what Christofleau was doing a century earlier with copper wire. The results were difficult for skeptics to dismiss. Germination rates increased by roughly 50%. The plants that grew from those primed seeds developed significantly larger leaves, deeper and more extensive root systems, and a notably higher tolerance to salt stress and difficult growing conditions. Then came the study that tested the original copper method directly. In August 2025, a research team from Marquette University published a carefully designed experiment in PLOS One, one of the most respected open-access scientific journals in the world. The team placed passive copper dowels, simple copper rods, not wired to any power source, in container gardens and measured what happened over a full growing cycle. Their measurements confirmed what skeptics had long questioned. The atmospheric voltage captured by a short copper rod, especially indoors, is very small. Only 2 to 20 millivolts, barely registering on sensitive instruments. But here is where the results got interesting. When the copper was buried in soil alongside root vegetables, turnips and beets, the plants produced a statistically significant increase in biomass. Both the above-ground foliage and the below-ground root mass were measurably larger and heavier than the control group grown without copper. The difference was real, reproducible, and passed the statistical threshold that separates coincidence from evidence. Scientists continue to debate the precise mechanism. Some argue the effect is primarily electrical stimulation of root cells. Others point out that trace copper leaching into the soil acts as a beneficial micronutrient. The truth may well involve both. But the bottom line stands firm. The 1920s technique produces real, measurable, scientifically verified biological enhancement in plants. Those old-timers who swore by their copper wires were not imagining the results. They were ahead of the science. 6. A simple weekend setup. No heavy lifting required. So how does all of this knowledge translate into something practical? Something a gardener can set up this coming weekend without hauling bags, mixing chemicals, or spending money at the garden center. The whole process begins with a roll of bare copper wire from the hardware store. It must be uninsulated, no plastic coating, no enamel, no lacquer. That bare metal surface is what catches the atmospheric charge. One roll is enough for an entire garden, and it stores easily between seasons. Take a piece of wire and shape it gently into a spiral, about 30 centimeters across, roughly the width of a dinner plate. Leave a straight tail at the bottom, 15 to 20 centimeters long. That tail is the anchor that goes into the soil. The spiral stays above ground, reaching above the height of the surrounding plants to maximize its exposure to the atmosphere. Next comes the mixture that early electroculture practitioners called a bioelectric catalyst. It costs nothing and takes 60 seconds to prepare. In a bucket, combine roughly 4 tablespoons of hardwood ash with 3 tablespoons of used coffee grounds. Add 1 liter of water and stir. Let it sit for a day. During that time, the minerals in the ash dissolve into the water, and the coffee begins to break down, releasing organic compounds into the liquid. What results is a mild, electrolyte-rich solution, a simple soil conditioner that primes the ground to conduct the microcurrent from the copper wire. Walk out to the garden with the copper spiral in one hand and the bucket in the other. Push the straight tail of the wire into the soil about 15 centimeters deep, right beside a plant that could use some help. A struggling tomato, a tired row of root vegetables, a rose bush that has seen better days. Then pour the ash and coffee mixture directly into the soil around the base of the wire. That is the entire process. 5 minutes. No special tools. No strain on the back or knees. No protective gloves or masks needed. Just copper, ash, coffee, and a patch of soil. Now step back and let the system work. The copper pulls microenergy from the atmosphere. The ash-enriched soil conducts that energy to the roots. The coffee grounds hold moisture, and begin attracting earthworms. The change does not happen overnight. This is not a chemical shock treatment. It builds. Over the first few weeks, the soil around the wire begins to darken. Earthworm activity becomes visible. Roots push deeper into the ground. Plants stand noticeably taller. Foliage fills out. Pest resistance improves, not from any chemical barrier, but from the sheer vitality of a plant that is finally receiving all the energy it was designed to absorb. Early experimenters had a name for this slow, quiet transformation. They called it soil resurrection. It is a fitting name. The soil does not just improve, it comes back to life. No heavy bags carried from the car, no chemical smell lingering on the hands, no receipt from the garden center, no repeat purchase next season. Just copper, ash, coffee, and time. A garden was never meant to be a battle against the soil. It was always supposed to be something simpler and quieter than that, a partnership between the earth and the person who tends it. Somewhere along the way, that partnership got buried under layers of synthetic chemistry, glossy marketing, and the assumption that the only way to feed a plant was to buy something in a bag. But the old knowledge was never truly lost. It was just waiting for someone to pick it back up. 100 years ago, a French engineer proved that the sky itself could feed a garden. Today, university laboratories are confirming what he demonstrated with copper wire and patience. The science has caught up. The method is simple, and the only investment it asks for is 5 minutes and a willingness to try something the garden center will never put on the shelf. Plant the wire, mix the ash, pour the coffee, then sit back, watch the soil darken, and decide whether the old ways still have something left to teach. That is all for today from Rooted Grace. If this method changes something in your garden, leave the story in the comments. Every experience helps another gardener decide to try it. And if someone comes to mind who has been dragging those heavy fertilizer bags for too long, send them this video. Sometimes the best gift a gardener can give is a trick that saves a tired back. Keep your hands in the dirt, keep your eyes on the sky, and may the garden always grow.